Kia ora, Year 12 and Year 11. This video is going to go through two of the harder questions from last year's paper. Both of them are applications questions where you've got to think about how you set up an equation. So here's the first one. If you're in my class, it probably look a bit familiar because I've made up some that are a little bit like this. So David has mounted a square photo on a square piece of card as shown below, and the border around the photo is of constant width. The photo has got sides of length n minus 2 centimetres and the card has got sides of 2n plus 6 centimetres. And we're told that the area of the border is 200 centimetres squared. Our job is to find the width of the border. So let's first of all figure out, well, what is the width of the border? Because it's not that hard to work out. I know that the width of the whole thing is 2n plus 6. And the width of the photo is just n minus 2. So I've got border here and I've got border here. So the difference between these two numbers is going to be twice the border. So let's start by saying that. So 2 times the border, or the border width, is equal to 2n plus 6 take away n minus 2. So that gives me n plus 8. So what's the width? Well, the width is going to be half of that. So it's going to be half of n plus 8, which is n divided by 2 plus 4. So we're just going to park that there for now. And that's actually, in some ways, that's the hardest bit of the whole question. Now let's think about what we know about the total area of the border. We know it's 200 centimetres squared. There are some hard ways to do this, and there's a really easy way to do it, which is to say, well, if the area of the border is 200 centimetres squared, all that is the area of the whole thing. Oh, what a big mess I'm making. There we are, the area of the whole thing. And now I want to change my pen colour, but that might be too much. So take away the area of the photo, right? So the border is the leftover bit. And we know that it's 200. So what's the area of the whole thing? Well, it's a square with this area, 2n plus 6 squared. Take away the area of the photo, which is n minus 2 squared. So all we have left to do now is to expand this and then solve. Okay, so sorry about that. I'll just keep going. So we're just going to expand everything out, but I'm going to do it on a new slide. So you can take this question from here and see how far you get. But remember, what we've got to find is the width of the border. Okay, so expanding, this is what I get. 200 is equal to, well, I'll write it out again. So here I get 4n squared plus 24n. I could have taken out the factor of 2 first, but that's okay. So plus 36 minus, now put this in brackets so you don't screw it up, n squared minus 4n plus 4 for this bit here. Be really careful with those brackets. Okay, now we're going to have 4n squared plus 24n plus 36 minus n squared plus 4n take away 4, right? A big mess, but it's going to crunch down to give me 200. The area of the border is 3n squared plus 28n plus 32. To solve a quadratic, we want it to be equal to 0, so we get 3n squared plus 28n minus 168. Now, I can fiddle around with factorising it, but it's not going to work. So you can use the quadratic formula, or you can chuck it into your calculator. And in the interest of moving on in the video, that's what I'm going to do. So we get two solutions. One of them is negative 13.49, and the other solution is n is equal to 4.1525. Reject, n must be positive because it's a length. And so this is going to be my solution for n. But remember, we haven't finished because the border width is n over 2 plus 4. So that equals 4.1525 over 2 plus 4, and that works out to be 6.07625 centimetres. Now that's a stupid answer to give because it's way too precise. So we're going to go with 6.1 centimetres to 1 decimal place. Okay, so I've got one significant figure more than what was in my original, which was 200 centimetres squared. Okay, so that's the first applied question that I'm going to do, and that's a merit question. The next one, oh no, actually I think that might be an excellence question. I have to check in the schedule. I'm pretty sure it is. This next one is definitely an excellence question, even though in some ways I reckon it's a little bit easier. So we've got a teacher who's hired a school bus, and the bus costs a total of $560 for a trip. It's going to be shared equally between the students, and at the last minute, 3 of the students couldn't go. So this means that the cost to those who did go went up by $1.50. So how many students finally went on the trip? So we're going to start by saying let n be the number who, let's do the n be the number who were originally going. It doesn't matter, right? It'll come out. You'll see that it comes out the same whichever way you start. But that means that what we had is we had the $560 being shared among n people. And we know that that's the same as the $560 being shared among 3 fewer people, but it's $1.50 cheaper. Okay. Another way to look at that is to say that the 560 over n plus $1.50 is my final price. Okay, so this is the final cost per student, and this is the original cost. It's worth checking that you've got that the right way around, but we can check it at the end of the question as well. So don't freak too much if you're going, oh, why did she do the subtraction and not the plus? The main thing is that you've got one group where you've got divided by n and one where you've got n take away 3. If you've done this on your own and you've done it the other way around, and n is the number who end up going, this bit will have an n plus 3. Okay, I hope that's clear as mud. What I'm going to do now is I'm going to go on and I'm going to solve that equation, solve it for n. Okay, so we end up with a quadratic, of course, because that's all we ever seem to get with level 2 maths, and actually a whole lot of real life maths as well, like this one. So we've got that problem there. Let's get a common denominator on the left hand side. For once I'm going to be happy working with a decimal. So let's just go over what I did there. Right, I want this to be over n minus 3, so I multiply it through here. Okay, next step, I'm going to expand this, the numerator. But I'm actually not, I'm just going to cross multiply everything now and clean it up. So we get 560 plus 1.5n minus 4.5 is equal to 560 times n minus 3. You'll see why I haven't bothered to clean this up in a second, hopefully. So here we get, whoops, that's times n in there. So 560n plus 1.5n squared minus 4.5n is equal to 560n minus, what's that, 1680. Right, now this and this can be subtracted from both sides, leaving me with 1.5n squared minus 4.5n plus 1680. So that's the quadratic that we should end up with. And solving that, Again, I'm going to use my calculator on that. Okay, gives me two solutions. It gives me n is equal to 32 or negative 35. So now we're going to go back and figure out what is that n? Is that the number of students who actually went in the end or the number who we're going to go to start with? So let's check that. It's really easy to check it. We've got $560 and we're sharing it among 32 students. What does that work out to be? Well, that's $16. Originally, n was going to be 3 higher. So n plus 3 was 35. And if we do 560 over 35, we see that we get $17.50. So we should be really happy with that because we know how many students went on the trip in the end. It was 32. The only thing left to do is to say how many students went on the trip. So let's do that to finish this off. 32 students went on the trip. So there we go, right? So the hard bit with some of these questions that you'll find is learning how to set up the equation. The best thing to do is just always start by saying let something be equal to something. Okay, so define a variable and just work with it from there. There will often be more than one way to go and it should all come out in the wash. Okay, leave me a comment if you're confused about any of that or send me an email to my school email address. Thanks for watching.